Everything we've done so far was built to drive you toward one singular moment in your engineering career. This one moment will open many doors for you while closing others. Engineers that are able to reach this one moment will be rewarded for investing so much so early into language models, prompt engineering, context engineering, agents, and ultimately agentic engineering. We've been building up to the code base singularity. Let's begin the final lesson of Agentic Horizon with the most important idea from tactical agentic coding and work our way up to the code base singularity. Out of all the tactics, concepts, and agentic patterns we've discussed throughout 13 lessons together, there is one mental framework that sits at the center, an idea so important that if you capture it, it can change the way you engineer forever. The agentic layer. This is the new ring around your code base where you teach your agents to operate your application on your behalf as well and even better than you and your team ever could. Focusing on building the agentic layer of your code base is the highest return on investment action for any engineer in the age of agents we live in. Why is that? As you know, when you scale your compute, you scale your impact. We're not just AI coding anymore. Our agents can take actions on our behalf. And this has changed engineering forever. Prioritizing agentics means going all in on this idea. It means going all in on compute as the best new tool for engineers to CRUD, manage, and manipulate systems of information. Compute, in its most useful form, is in a prompt and a loop with tools, the agent. This transformed the big three into the core four: context, model, prompt, tools. A powerful abstraction that lets you talk to information itself. After 13 lessons, you understand this now. You know that the leverage points of agentic coding fundamentally change what a single engineer can do, and therefore it changes what your team can do and what your company can do. In our final lesson together, I want to solidify everything you've learned into a comprehensive roadmap for building agentic layers. By the end of this lesson, you'll understand the different shapes, stages, and components for building real agentic layers for new and existing code bases. And you'll understand what the next step is for improving your agentic layer. Software is always evolving to better solve your users, customers, and clients' problems. The current state of your code base is only a step to the next state of your code base. We'll be putting together big ideas from tactical agentic coding and Agentic Horizon to round out your experience here. It's been incredible creating this for you over the past year. Since its launch, thousands of engineers that know agents of the present and the future have upskilled what they can do with powerful tactics of agentic coding we've discussed here together. If you take these ideas in these courses and put them to work, as many already have, you will accelerate past the industry into a new role of engineering, agentic engineering. Here, we build the system that builds the system. Owning the agentic layer and knowing how to build them at will, at scale, will make you an invaluable, irreplaceable engineer. I mean this when I say this. If you do this right, it will change everything. There is a massive career-changing opportunity that will emerge as you build your agentic layer. A moment in time, singular in nature. Once you've built a sufficiently powerful agentic layer, something will happen. The code-based singularity. In this moment, you, the engineer, will realize one simple fact. My agents can now run my code base better than I can. I trust them to ship more than I trust myself or my team. Nothing ships to production without my teams of agents. Yes, this might sound crazy, it might sound far out, but if you've been pushing what you can do with agents, if you've been putting these tactics to work already, maybe you already see this future on the horizon, the agentic horizon. I can tell you this for certain. Right now, there is an agentic layer that could exist inside your code base, so powerful that your code base runs itself. The only question now is, do you know how to build it? Bridging this gap is going to be a key part of our mission here in the final lesson. As we work through building agentic layers, keep this idea in your mind and think through what it would take for you to trust your agents to run your code base better than you could, from prompt to production. I'm not saying this will be simple, but with everything you've learned so far throughout tactical agentic coding and Agentic Horizon, this is now a potential reality for you. In this lesson, we're going to put together the missing pieces and see how we can attain the code base singularity. There are 3 concrete classes of the agentic layer: class 1, class 2, and class 3, each defined by a unique element that makes them distinct from the rest. Our whole goal here is to look at the components, the raw elements that make up the new ring around your code base, where you have agents drive your engineering experience and you drive your agents. The green squares here, the outer layer, this is the new agentic layer. The inner layer here, right, these dark squares, this is going to be your application layer. And we're bundling a ton of things underneath your application layer. We're talking about your database, your front end, your back end, your scripts, all the application stuff, even your DevOps stuff, right? This all goes underneath the application layer. Why is that? It's because we want to be able to bundle your different repositories underneath your agentic layer, so that we can do something like this. Code bases often contain more than one application. So by bundling your agentic layer around your applications, right, every single application that's related to this product, your agents can effectively see everything. Every class is going to have 1 to n grades that will give you a rough understanding of how powerful your agentic layer is. You're going to be able to quickly identify where you are as we move through classes and grades, so that you can make improvements and get to that next level. So look to increase your grade, and then once you reach the limit of a certain class, look to make that next jump uniquely identified by a new dimension that we'll talk about as we progress from grade to grade, from class to class, all the way up to class 3 and the final grade. Now, let's start by looking at a powerful version of a class 3 out-loop agentic system with an orchestrator guiding the workflow. Let's just jump to one of the potential code bases that you could have, that you could build. You've seen powerful systems like this in our previous 2 Agentic Horizon lessons on multi-agent systems and agent experts. What we're going to do now is run 2 brand new workflows and combine some really big ideas that we've discussed throughout tactical agentic coding. So I'm going to open up the prompt interface here as usual, and you'll notice we have one new section, the highest leverage point of agentic coding. Our orchestrator agent can now kick off AI developer workflows. I'll paste in this prompt here, and I'm commanding the orchestrator agent to kick off this specific workflow in this specific directory with just a single simple prompt. We're not overcomplicating this. I just want to show you so that you have a concrete vision of the types of systems you can build out. So we're going to fire this off here. Let's go ahead and run another. Let's go ahead and build out a markdown preview application here in one shot with our plan, build, review, and fix. And this is an AI developer workflow, so the orchestrator doesn't need to do anything, right? This runs end to end. We're going to run one more workflow here, and then I want to show you something awesome. You've seen the generic log stream view. We have pushed our orchestrator to be able to control AI developer workflows. We have concretely placed it in its own user interface. We now have full-on UIs to monitor, understand, and really preview our applications getting built out with our agents end to end. We now have 2 workflows running. So plan, build, review, fix, and just a simple plan, build. We have given our orchestrator agent the ability to run arbitrary end-to-end workflows. This is what the future of engineering looks like, fine-tuned to your specific domain, to your specific use case. This is one version of the end vision of how to really scale your compute to scale your impact. Now let's dial in and start from 0, right? Let's reset, because we don't start here. We don't start at class 3. We don't start with powerful orchestration systems. We start with nothing. So as mentioned, every single code base should now have these two key components, the application layer and the agentic layer. These two squares here represent a brand new code base. Now, oftentimes you'll be operating in an existing code base that will look like this, right? You'll already have some pieces, right, modules, files of your application layer, and then you'll start adding on your agentic layer around your code base. Now, what does this really look like? Let's start from a greenfield, brand new application, just to make this all clear. What exactly is in our agentic layer? This is our class 1, grade 1 agentic layer, the thinnest possible agentic layer you can have. A small amount of code, and you have a prime prompt and or memory files. It doesn't get thinner than this. If you have this, you technically have an agentic layer. Now let's dive into a concrete code base structure to see what this looks like. Okay, this is an example project structure. We're going to work through several of these to make it absolutely clear what it looks like to have an agentic layer surrounding your application layer. All right, so we have application layer files, folders, directories, so on and so forth, and we have our agentic layer files. If we open up .cloud here, .commands, we can see we have this prime command. As you know, the prime command effectively represents a memory file, but the big difference here is that you can activate this whenever you want to, and you can fine tune the prime command to run any specific workflow you want to. Okay, so this is just a prompt that effectively activates your agent to read specific files, right? So there's nothing new here, right? We have a classic agentic prompt. .cloud, of course, is our memory file that's always going to load. You've seen this, you understand this, you know this, and oftentimes I like to take the agents.md if I'm working with other agents and just reference that claude.md memory file. This is the simplest possible agentic layer. Now, in our application layer, if we're going to user management, where we have a backend for a user management system. This is just a starting place, right? This is a great way to, when you're creating a new application, just start with something. An agent can come in here and understand how to operate this right away with the memory file and with the prime command. Okay, so as we work through classes and grades, we'll talk about the compute advantage you get by scaling to this class and grade of agentic layer. And then we'll of course talk about trade-offs. So the compute advantage here is obvious, right? We get a clean, minimal setup. It's a great foundation for agentic growth, and agents understand context immediately. It's a super small code base. This is easily reproducible by anyone. There's no value in a code base this small. It's useless for large code bases. Limited capability, and there are many leverage points of agentic coding that the class 1 grade 1 agentic layer purely misses. Let's scale this up. Now we have the class 1 grade 2. This is where we start surrounding our code base with more useful leverage points of agentic coding. Here we incorporate specialized prompts to help us plan work. We have a prime command, and we now have access to agents, also known as sub-agents. Here we can start incrementally improving what our code base can do. So let's go ahead and look at what this code base looks like now, right? We have a new specs directory where our plans are written. You're very familiar with that pattern. We also have AI docs, so our agents can pull in documentation to aid their context. This is all part of the agentic layer, and our user application is starting to grow. We have a few tests, we have modules, but the most important pieces are here. In addition to our commands, right, our raw prompts, we now have some sub-agents or just some agents that we can run, right? So for instance, you might have a fetch docs sub-agent that will save them in the AI docs directory, and you might have a test writer. These are just simple examples of starting to scale up your agentic layer. You likely have something more powerful than this, but we're just working our way up. And now you might have something like a brand new plan file. So when you're doing work, you might prompt this plan file and then execute it. Very simple. We're still just stacking things up, slowly building up our agentic layer. This is a simple class 1 grade 2 agentic layer. The big advantages here is that we have specialization with sub-agents, and we can scale this and parallelize certain workflows. All right. And now we're starting to collect documentation for our agents, and we're planning our work before we implement. So this is grade 2. Many engineers have passed this level. This is not that novel. It's not that interesting. We're still limited in many ways, right? The big thing we're missing here is custom tools, which brings us right to grade 3. So in class 1, grade 3, things start getting interesting, and our agentic layer starts to wrap our application layer. So here we have 3 key new pieces: skills, MCP servers, and prime commands with tool access. You likely already know what that is. All of these 3 things give us the same thing: custom tools that enhance our agent's core 4. Let's take a look at what this actually looks like in an agentic layer. Class 1, grade 3. Now we have a couple additional base level files. You might have a .mcp.json, Postgres, Firecrawl, Jira, Notion, whatever tool you want to use, you can now throw it in here. But that's not all. We know that MCPs are very token heavy, and we can just prompt engineer properly to get our agents the tools they need. One of the ways that can be done is with skills. Our agents have learned to migrate the database. And so inside of this file, you've seen these before. We have taught our agent how to use a specific tool, and it can now use it to perform a specific task. We're starting to specialize our agents a little bit more outside of our sub agents. But we can also do things like this, right? Start and stop application. If we open up this skill, we are just teaching our agent how to use scripts. There's no need for an MCP server oftentimes. You can just build your own script that exposes the right functionality. Here we have a start and a stop tool that starts and stops the application. Okay, so we're just scaling up what our agentic layer can do. We're giving our agents more capability, right? We are scaling our compute to scale our impact. Our agents now have access to custom tools, skills, and prime commands, right? And keep in mind, this is something that I want to keep emphasizing. Skills and MCP servers can both be replaced with just a simple prompt. Okay, so we have this prime DB with tools. You can teach your agents how to execute CLI commands. Here, we're just using PSQL, right? So that our agent knows how to interact with the user management database for this mock application. And so you can bypass everything by just understanding how the core 4 works: context model, prompt, and tools. Okay, and notice what we're doing here, right? We're constantly giving our agents more capability. Custom tools is a huge step. Grade 3 is very important. Now, this is when prompt engineering, context engineering becomes more important. Skills, MCP servers, and prompts must have tools carefully designed. This is where things can start going wrong. And a lot of engineers do get stuck at grade 3. They think they get past this, but actually their tools are terrible and they won't scale, and they're chewing up tokens, they're burning cache, and they're over-engineering their tools, right? Like one of the most common problems is that engineers will have way too many tools, and they need to actually learn how to build tools and give their agents just what the agent needs. Designing tools is an entire game on its own. This is one of the ideas we talked about in the custom agents Agentic Horizon lesson. Being able to design and give your agents the right tools via MCP server skills and just raw prompts is a critical skill for every agentic engineer. Let's move on to grade 4. How do we scale this up even further? What comes next, right? So at this point, we start scaling up our prompts and we start building up feedback loops in the code base, okay? So this is where things become very powerful and where you can really scale what you can do. So of course we have our plan prompt, but now we'll have things like our build prompt, right? A higher order prompt. Grade 4 is distinct in that you start asking your agents to review their work. This is where you realize that you should always add feedback loops into your agentic layer. You're effectively adding more compute to get more confidence in your agent's results. All right. This is the big idea in tactical agentic coding. Lesson 5, right? Always add feedback loops. Here we're building closed loop prompts. All right, let's understand the application structure. So now we have things like app review. So not only are you planning your work, you're having your agents review the work done and then report it. And you're doing this with powerful prompts like the code review prompt, the review prompt. You're then running reproduce bugs, and then things like test backend, test frontend. All right. So for instance, what does review do? Code review current changes, review all stage changes, do a bunch of stuff, and then we're going to output some concrete results. You might also do something like reproduce a bug. This is where we would save a concrete resolution file into app reviews. This becomes really powerful when you start giving your sub agents these abilities. Okay. So we can run something like a review agent, and you can scale this up, and then it will output its review into a specific file. Inside of our application layer here, you'll also notice something. As you start to grow your code base, your agentic layer and your application layer will be growing side by side. We've now split out our application into client and server. At some point, your small code base will grow and it will start to fracture. This is important. We'll look at this in the next grade. But with this application directory structure, we're still able to keep all related code for this product under the same code base. Now, how this operates in Git is important. We'll talk about that in just a moment. Since we have both a front-end and back-end application, you can start specializing your prompts, right? Test back-end, test front-end. Here we have a concrete closed loop prompt. I'm being really verbose here with my language inside of these mock prompts. We're following that 3-step workflow from tactical agentic coding, lesson 5, request, validate, resolved. This creates a closed loop where your agent can spin and spin until the job is done. This distinctly marks grade 4. Again, this is a place where engineers fall off and they miss out on using more compute to get the job done. Right? We're starting to split our prompts to focus on specific areas of this code base. Okay, so things are going from really generic and vague, right? Plan, build, to more specific, right? Test our backend, test our front end, review this code how we like to do it, right? And the advantages here are really clear, right? Once you start using closed loop prompts in your code base, your agents start resolving their own work. You can create specialized tasks for your front end, for your back end, for whatever part of your code base, and it's all still on this top layer. Now, we're not going to dive into code base organization too much here. There are some leverage points of agentic coding that we're not going to re-emphasize here. Here, we're focused on giving our agents the highest capability possible so that they are as autonomous as possible. Now, there are some trade-offs here. Again, things start to get more complex. You need to know how to prompt engineer. This is why our agentic prompt engineering lesson was so important. You must know how to write these prompts properly. Self-correcting agents is a massive, massive win for your agentic layer. Let's move on to grade 5. How does our agentic layer continue progressing? Now, by this point, many engineers have many prompts, many agents, several skills. They've used many different types of MCP servers, and they start scaling their work even further with a key concept we discuss in lesson 3, templates. Now, many engineers don't realize they're writing templates, but this is where you really start templating your engineering, where you teach your agent how to build like you would. As you know from TAC, we have bug, feature, chore. For our front end and back end application, we'll have things like new API endpoint, update API endpoint, test, new API endpoint. The big distinguishing factor here is templates. Now let's just look at the advantages here and then we'll dive into what these look like exactly. Templates are structured plans with specific output formats for different types of work. Okay, this lets you customize how you want your agent to build. This is where you can truly template your engineering and teach your agents to build like you do, right? And the most straightforward example of this is something like the bug. All right, so when you open up the bug, you can see a very similar format. This was repurposed from TAC. We're now having our agents output a specific format, right? A specific output plan file that will then execute. This is ultra powerful because you get to detail what your agent does, right? So not only are we giving high-level instructions, we're saying, hey, fill this out. This is how we solve bugs. These are the steps. These are the relevant files. Here's how you're going to organize your steps individually. And then at the end, we always run that validation, right? We are embedding our closed loop prompts, add more compute to add more trust in our systems. And we're embedding this, right? We're templating this into our prompts. This distinctly identifies grade 5. This is kind of hard to see. If you're just building out these random ad hoc prompts, it's hard to see this distinguishing factor between a plan and a template, but it is massive. When you start building templates, your agent starts operating more like you would. Because for instance, right, the way you solve a bug is very different from the way you solve a chore or write an entirely new feature, all right? Of course, for a feature, you're gonna need to be a lot more detailed. You wanna understand the user story, right? What are the technical design choices here? How do we organize this in the back end, the front end, and the API layer, right? There's whole levels to this. And this is where things become really powerful, and it's where specialization continues. All right, so, notice something here. Let me call something out here. Our application layer has now split in two. We now have two code bases that our agentic layer is going to wrap. Now, this is a key thing I've discussed with many engineers. This is the winning code base structure for this. You want all of the actual application layer code to run under apps. And if they're coming from a different Git repository, I highly recommend you set up Git submodules. This is the solution for this. You don't want to be referencing multiple files in different directories. You want your agents to be able to just come in here very cleanly and use all the available prompts, subagents, skills, whatever agentic pieces you have, right? Agentic primitives. You want them to be able to see all these and just operate on your application. All right, so I'm talking database, client, server, DevOps, infrastructure, all of your notebooks, right? All your data science notebooks. You want them to be able to see everything and have it all co-located in a single place. This makes it really easy to scale up while keeping your code bases separate. So for instance, your server user management can be in its own separate Git code base. These language models, they know how to operate Git just fine. Say you have 5 applications here under your application layer directory. That's fine, right? You can have 5 different teams of engineers working on all of these, right? Obviously, just to be clear, you want these to be related code bases that help fuel a product experience, right? If you don't need your agent to see multiple code bases at the same time, it's fine. Have them be separate, duplicate your agentic layer, right? Build it out separately and, again, specialize it. Engineers go wrong here too. They think they need to build a generic one-size-fits-all agentic layer. That is not what we're doing here at all. Your agentic layer should be specialized to fit and wrap your code base. Okay, make it specialized, right? And that's where templating becomes really important, because you really start to shape all of your agentics, all of your leverage points of agentic coding to your specific code base, to your specific use case. And by doing that, you build a distinguished, unique product experience through your application layer and through your agentic layer. Okay, so push into making your agentic layer unique and specialized for that one code base. Don't focus on reuse, right? Focus on making these prompts great for that one code base, okay? Compute advantage is exactly what you would think. Agents fill in your templates, bug, feature, chore. We can now build specific prompts for specific problems that we solve in this code base, all right? Trade-offs, of course, with every class and grade we move through, we have to invest in this, right? And over templating can reduce agent flexibility. This isn't usually a problem, but it is something that can come up if you're defining these structures that are too strict, that don't capture the full scope of the work you're trying to do. And templates should evolve as the code base changes and evolve. The big trade-off with a lot of your agentic layers is going to be, you're going to have to maintain this. You're going to have to grow it, okay? The agentic layer is a unique investment. Now let's move on to grade 6. So things have expanded, right? Your code base is growing, your product is successful. It's not enough to just run a single prompt. You're now at the stage where you are prompt chaining, or you're running agentic workflows, right? So now one prompt now references many prompts and or sub-agents and other skills, okay? For instance, the most concrete example of this is the plan build workflow. First, you write the plan and then you build it. You can have two separate agents do this work. You can have one agent do the work. We don't want to violate tactic 6 too much, but when you're starting, anything is on, right? Just get the job done. So what does this look like in a concrete code base? Let's take a look. So we're just going to fast forward here. I just want to reveal everything so it's super clear, right? This is a massive step in your agentic layer. When you start chaining together prompts and agents, you are building out the first versions of the most powerful leverage point of agentic coding, the AI developer workflow. Okay, so this is ultra powerful. Let's take a look at this. Let's look for one of the most foundational ones here, right? Plan build. So plan build looks like this. Create a plan and then build it. It doesn't get simpler than this. Run our plan prompt, we capture the path to it, and then we execute build on it. The big decision that you're gonna have to start making here with your agents is, when do I start building out dedicated agents? When do I use sub agents? When do I use skills? That's all up for you to figure out with what works best for you. I'll say this, I always recommend you have a prompt, just a raw command that you can run that does everything in bits and pieces. So I would absolutely never build a plan, build, review workflow that cannot be run individually. You want to always be able to run plan on its own, build on its own, and review on its own. Why is that? It's because if you slam this all into one and you can't run the individual pieces, at some point something will go wrong and you will not be able to isolate the one thing that went wrong. This also makes it hard to scale these into concrete sub-agents that you can then run in parallel and scale up quickly. Another huge advantage is that when you're building out a skill, or again, a prime prompt that references other prompts and skills, right? Just like what a skill would be, you can concretely reference other prompts inside of your skills. Just like you can give your skills specific tools, you can give them specific prompts. And you can say, only run this prompt when X, Y, and Z, okay? Remember, everything is just a context model and prompt. It doesn't matter what it's called. It can be called a skill. It can be called a prompt chain, agentic workflow. When you're running agents, the core 4 is everything, right? Everything eventually becomes a core 4, all right? This is powerful. So we're now chaining together prompts. We have reusable, isolated, right, primitives that we can then run individually or chain, okay? And this gives us composability. You can mix and match your prompts and your chains and your agents. And now we start creating small teams of agents, right? And what's a concrete example? Scout then plan prompt, right? You can see we have a multi-step workflow where we're going to launch parallel scouts, and then we're going to collect scout results. We're going to synthesize all their findings into a single file, again, in our app reviews. You can store this in app docs, wherever you want to store it. And then we're going to run plan with scouts. So before this agent runs and does, the main work, we first run sub-agents to research and look for information, okay? The exact details of this prompt, they don't matter. You've seen prompts like this before, but the key is this. You want to be able to chain together prompts to create composite workflows, right? Also known as prompt chains or agentic workflows, right? Series of steps, okay? Now, of course, the limitations are all very obvious, right? You must know what you want to build. You have to know what you're doing, because when you start chaining together at this level of complexity, things can fall apart very quickly, right? These can also be harder to debug, especially if you start throwing everything in a single agent, and especially as you get close to that context window limit, right? We talk about the R&D framework. We talk about a lot of ways to get around these problems in previous lessons. Feel free to reference those lessons as you work and run into these issues over and over. For the next few years, everything is just managing your core 4 and then scaling it up with more, better, custom, and orchestrator agents. We'll get to that in a moment here, all right? Context engineering becomes not just important, but it becomes a requirement at this stage. At this point, you must be adopting your agent's perspective. You can't write a 5-agent long prompt chain without knowing the context that every agent will have at every step, right? So context engineering becomes just a raw requirement at class 1, grade 6, all right? How do we push this further? We've already got so much going on at this point. A lot of the work we do now is just in doing more, right? How can we have our agents do more? How can we set up larger change and have more capable agents, right? That's what this is really about. I fully recognize there are other important directories and ideas, right? Hooks, setting up logging structures. That's all great. We're talking about raw capability here, not security. We're talking about what's the most capable agents we can deploy to build the most powerful, the most autonomous agentic layer, all right? So I fully acknowledge, just want to call that out real quick. I know some engineers are thinking, what about this directory? What about that? We're focusing on raw impact, logging, not observability. It's just impact, okay? So we're going straight down the line of impact. By class 6, grade 6, you can use prompt chains and agentic workflows to tie together agents and other prompts to do large amounts of engineering work in a single swing, right? Because remember, you just write that initial incoming prompt for this, right? Task description, and then your agents handle it from there. But by this point, you have to have adopted your agent's perspective, right? There's no way around that at this point, all right? So, big fall off curve here. We're probably in, top 15, top 10% of engineers using agents, and it continues. Here, there's a big drop-off point here. Let's talk about grade 7. Things have really scaled up. You now have a large 2-application code base. Your agentic layer is growing powerful. You have a ton of prompts, sub-agents, skills, right? You're managing your code base. And this is where I think you can really start to see signs of your agents starting to run the code base better than you can, okay? It's at this level. I've seen it time and time again. Once you start building experts into your code base that really understand specific areas with that mental model in combination with prompt chaining, this is where we start to see your agents solving problems end to end without you. This is where tactic 7 shows up, where we are targeting zero-touch engineering, and that leads us right to the doorstep of the code-based singularity, right? Once you start getting these one-shot end-to-end prompt to production workflows, it becomes very clear, right? You start to see the code-based singularity right in front of you, and experts are a big piece of that. Class 1, grade 7 is uniquely identified by agent experts. Okay, so let's just walk through this. We touched on this in our previous lesson. Many engineers are going to gloss over that. The exact structure of this does not matter. It only matters that you have some agents keeping track of their mental model of a problem. All right, .Cloud commands experts a specific topic or area of focus in your code base, and then you have expertise file that tracks a mental model. Again, not a source of truth, a mental model, and then you have prompt chains, right? Agentic workflows that can run, and you have the individual prompts specialized. Once again, you do want to specialize. That's the whole point, right? Your code base is literally a specialized solution to solve a problem. So don't try to build everything to be generic. Build it to be specialized, okay? Build to win for the use cases you care about. Agent experts are the ultimate version of that. They give you domain-specific mental models. They give you agents that just are always tracking, always keeping track of certain areas in your code base. Again, this ties directly into Tactic 7, Tactic 8, and it leads us to code bases that run themselves. I hope you can see that. I hope you can see that's, we've been slowly building up to all of this, right? Over every TAC lesson, over every AH lesson, it leads up to the agent expert. Okay. And of course, this is where agentic prompt engineering, context engineering, these are all now hard requirements. Okay. In fact, requires a high level of prompt engineering and context engineering. Okay. So, we talked about this before. You have a whole mental model an agent is keeping track of. It knows where file references are. It understands the kind of core underlying thing that a specific area of your code base manages. And then you have surrounding prompts, right? So you have a question prompt to ask questions to this expert when you're building or want to understand something, right? You can plan, you can build, and then of course you can chain it together. Okay. Now, again, I want to be super clear about this. It doesn't matter if this is a set of prompts. I always recommend you have a set of prompts to build off, but you can build this into a custom agent, sub agent. You can build it into a skill. You can build a prime prompt, right? You don't need a skill. Skill is just a markdown file that references other files. You can build this by hand. The composite type doesn't matter, but what does matter is always thinking about increasing your compute advantage with powerful techniques like this, all right? Because this gives us self-improving expertise, and then you can build specialized workflows on top of that. But this uniquely identifies a class 7, grade 7 agentic layer. You have built experts into your code base. I just want to be super clear. The form factor doesn't matter that much because everything turns into the context model prompting tools. The question for you is, do you have a specialized agent that can operate specific parts of your code base better than you can? Increasingly so. Again, all this stuff takes practice, right? I'm betting here that the next few years of engineering is spent building out these class 1, class 2, and class 3 agentic layers. This leads us directly to our next class 2, grade 1. This is where we start getting that second tier. Class 2, grade 1 is uniquely identified by one big change we talk about in lesson 4 of tactical agentic coding. As you can see here, we are now pushing into ADWs. We don't have a full ADW yet, but you can see we're starting to put together that second layer. Class 2, also known as layer 2, is where you build out an out loop system, okay? This is the Peter framework. This is where we are staying out the loop and we're making sure that our agents can operate our code base without us. Now, grade 1 is us building out the fabric of this. So we have, for instance, a webhook, so an HTTP endpoint that you expose, of course, with the right security and all that. This means you can call that endpoint through an external service. Slack, Jira, Discord, GitHub, right? We use GitHub in tactical agentic coding, but you can set up whatever out-loop system you want. But in this very first bare version, right, class 2, grade 1, you can just execute prompts against your code base from an external service, right, from out the loop. So your webhook calls your prompt, and then your prompt just executes against some core agent SDK. In our previous lessons, we have directly used the Claude Agent SDK in our building custom agents lesson. Check that out if you need a reminder, refresher on how that works. That is, of course, how we've built out our AI developer workflow here. This kicks off and then it fires off a slew of custom agents, right? All specialized to do one specific thing extraordinarily well, staying in line with Tactic 6. We have a planner, we have a builder. The big difference here is that we can now do any type of logging and investigation that we want to. Again, we're still building up to this powerful agentic layer. You can see how we're starting to get there. You need to be able to access your agentic layer from anywhere, specifically from out the loop, because by this point, you should have prompt chains that you can run end to end to get work done. All right, so let's just quickly take a look at what this code base looks like, right? It's been growing. We're building out new features. We're satisfying users, right? Our server and our client have gotten quite large now, right? We have a bunch of models, a bunch of routers. Our client has gotten larger, but we've kept track of all of it. We've been building our agentic layer alongside our application layer, and things are running very smoothly. Our agents run this code base, and we teach our agents how to do it the best. All right, so this is, our out-loop Peter system as covered in lesson 4, 5, and 6. All right, so class 2 is when you start building out your out-loop agentic system, because you don't need to be in the loop for so many tasks that you run. That small chore, that small bug, you absolutely are wasting your time. I guarantee you that. And class 2 helps you solve that problem concretely. So, as mentioned, right? ADW webhook, this can come from wherever. Webhook events from GitHub, when someone creates a new issue, you can fire this off from Slack, right? This is a super common one. Whatever it is, right? It all hits an HTTP endpoint that you expose in your agentic layer that then calls into your key agents. Now, here we are running agents via an agent SDK. So this is where programmatic agents, right, building your own custom agents becomes super critical. We talk about this throughout TAC. This is how you stay out the loop, right? This is out loop agentic coding. This is where we start building up a deterministic scripting layer for orchestrating our agents. And so we have that core agent SDK, which just defines all the SDK functionality, and then we can prompt against it. Now, you probably have noticed that we are missing the actual full AI developer workflows here. That is what defines grade 2, right? So at this point, your code base is very, very built out. You have lots of agents running around doing work for you. And now things go parabolic. This is a massive step in your agentic layer. Now we can run complete workflows that do specialized work on your application layer through your agentic layer end to end. All right, so let's keep in mind everything we've done so far. We've got class 1 agentics on that first layer, prompts, subagents, skills, closed loop prompts, prompt chains. It's all under that first layer, and we're just scaling that up over and over, solving different problems. And then we have our individual application layers. So we have our front end application, our back end application. All right, and this simple example, of course, in your code base and in code bases I operate, this shape is going to look very different based on, where you are, right? You might have a lot of green squares missing. You might have a lot of things that you should or need to build out on your roadmap. But that's the whole point of this, right? So you can identify what's your class, what's your grade, and how can you move forward. All right, so class 2, grade 2 is huge because we now have AI developer workflows. As mentioned, this is the highest leverage point of agentic coding. Why is that? It's because you get deterministic code plus non-deterministic agents. You get the best of both worlds. You get full control in between each agent step, right? We're talking logging, validation, retries. You get to track everything, right? This, let me be super clear, this is how this multi-agent AI developer workflow is running. Inside of your AI developer workflows, you can use anything to emit to your front end, right? I like to use WebSockets for this. You can pull, you can do whatever. In TAC, we looked at returning comments, right? Returning updates to the GitHub issue. You can do this to your GitHub PR. A lot of cloud-based out-loop agentic systems, they already do that, right? Instead of ADWs, we now have our agentic workflows. Okay, now this is massive. This is where you're going to get massive, massive value. Engineers that reach this point will be closer to anyone to the code base singularity and to truly controlling their code base from anywhere with the highest capability, because they know their agent's perspective. They know what will happen when they run these workflows. What do these concretely look like? We've already looked at these in TAC, but we have raw code that just runs the agents directly, and then surrounding it, we have whatever deterministic code, whatever logging, whatever event emitting we want to. We can validate, we can rerun, we can do anything we need to here. We can run any custom agent, any skill, right? This is the highest control, right? The highest leverage point of agentic coding. All right, so we get everything here. Of course, this all comes at a cost. We have to maintain all of this. We have to write all of this. All right, nothing is for free in engineering. Even with great new technology, we still have to put the work in. We need to build these ADWs. We need to manage them. We need to make sure that they run properly as we want them to. But the advantage here is clear and massive. We're letting our agents run things better end to end while maintaining high levels of observability and ease of testing, validating, and improving everything. All right. And of course, throughout this entire process, as you can see here, we have many, many, many additional prompts, agents, skills, yada, yada, yada. All right. So things are really stacking up. I think at this point, your prompt chains do start disappearing and they turn into AI developer workflows. All right. Once you find yourself deleting your agentic workflows and deleting your prompt chains and replacing them with the concrete AI developer workflows that run end to end with great logging and observability, you will be at class 2, grade 2. A lot of engineers, they are just going to go for that out-loop cloud-based agentic coding tool by some big lab, and that's going to be it. All right. That's fine, but they will not get the advantage that you have if you push through this and you build your AI developer workflows, because this is how you get the most control, and this is how you maintain your most important asset as an engineer, your code base, your application layer, your agentic layer. Moving on to the final class. There is only one thing that identifies this layer, this final class. We've covered it. It's a big idea, and agents of the future will be powered by this agent. This is the orchestrator agent, the one agent to rule them all. Now, in this level, we of course have everything we had before. Every grade, every class stacks. We have our 2 back and front ends. You might have additional code bases, right? You could have 4 Git submodule code bases here. You might have 6, right? It doesn't matter. As long as your agents can see everything, as long as your agents have full visibility and can tap into every code base, into every file it needs, that's what matters. We of course have our class 1 agentics on that first layer and our class 2 agentics on that second layer. Now we move to the orchestrator level, and it's quite simple. There will be almost no changes here except for this. Inside of your application or in a dedicated directory inside your ADW's directory, you will have an orchestrator. Now, it is not clear how to best build this or where exactly to place this. I have built versions where I have the orchestrator in its own application. It then references the ADWs, and this is how this application is running. So we have a nested application that references the agentic layer. This is okay. It's messy and there's a lot of code reuse, but you can also place this directly inside of the ADWs. You can make this entire application, and this is where things really require great engineering. Okay, it gets so hard to maintain all of this and to orchestrate your orchestrator agent, running other agents, but the impact here is absurd. It's absurd. Okay, so let's talk about this, right? So what is this exactly? This is what we've talked about in our multi-agent orchestration lesson, okay? This is a version of this, right? This, to be super concrete, what we have here is a working version of that exactly. We control our slash commands from here. We can reuse sub-agents and build them into concrete primary agents, right? Command level agents. We can see our existing agents, fixer, reviewer, builder, and we can see our orchestrator tools. Our orchestrator agent is a custom agent, right? Everything comes back to the core 4 and your ability to scale your agents from a base agent to a better agent to more agents to custom agents, and then ultimately to the orchestrator agent, okay? This pipeline runs alongside you building out your agentic layer. And the orchestrator agent itself represents the transition to a class 3 agentic layer. You have all these prompts, sub-agent skills, these powerful leverage points of agentic coding. You have these prompts, prompt chains, all these skills that you can stack and compose, different MCP servers that some agents work with while others don't need to, tons of sub-agents to parallelize and scale your compute. There's going to be a point where the orchestrator agent is the solution to controlling and best managing your agents, right? And all of your agentics, okay? So what you're effectively doing here is building a custom agent that is a lead engineer that can CRUD command and manage other agents, right? It's running CRUD on agents. This gives you centralized control over your agentic layer. This also operates as your out loop system. Now, to be super clear, you can have both, and your orchestrator agent can in fact just be in the terminal, right? This can be in the loop, but the best version of this will be an out loop system that again, you can customize and fine tune. You can build prompts and agents and skills highly specialized for your code base. So this is ultra powerful, right? Of course, the trade-off here is the same as it always is. You will need to maintain this. It is hard to build and it requires experience and skills above the rest of the pack. If you push through this, if you do this, you'll be rewarded for it. All right. There's no feeling like talking to an orchestrator agent that understands your problem. I use working versions of this specialized in production code bases I have, and it is like nothing else. When you truly customize an orchestrator that understands your agent experts, your AI developer workflows, and they can just chain together and conduct, right, and orchestrate intelligence on your behalf, it is a very, very powerful, not just feeling, but the results that follow that feeling. It is just absolutely mind-blowing. Okay, it's absolutely mind-blowing. I'm very happy that I've been able to get this into a place for you to see this vision. The next step for you here as we round out our final class here is to start thinking about what this looks like for you and for your code base, and to understand, what level are you at and what level do you think will be the most useful for you? Okay, let's round out our final 2 grades here. So once you have built your orchestrator, as covered in our multi-agent system lesson, you can now build out orchestrator developer workflows. Okay, so very similar to AI developer workflows, right? Let's go ahead and open this up, .claude commands right here. You've seen this if you've looked at this code base. What we can do now with our orchestrator agent is use it to conduct and orchestrate entire workflows. So this is going to feel a lot like a prompt chain or an AI developer workflow, but you can do very, very interesting, complex things because now you're prompting a orchestrator that understands your agents, your prompts, your skills, that then prompts and communicates back and forth with your command level agents. Okay, so there are very, very powerful workflows that can occur here, right? Because now you have, again, we have this multi-level conversation happening, getting work done with multiple teams, right? Your orchestrator agent can spin up, as you saw here, right? Multiple teams of agents focused on multiple problems. We don't want to violate tactic 6 at this level of scale. Things just get too complex. You want to have one agent with one prompt solving one problem, right? One agent, one prompt, one purpose. So the planner agent just planned, we can dial into any one of its logs. We can see what it was thinking. We can see, the summary. Every event, every individual event here is getting summarized by a summary agent, then reported back to us. We can dial into the main details if we want to. We can fire off system logs, right? That's all well and good, right? We need peer observability so we can understand what happened completely. Your orchestrator developer workflows are very powerful because it creates an open stream of communication. These agents, we can now talk to any one of these agents from this workflow at any time, okay? And we can continue, we can ask them questions, we can continue to push on these workflows, okay? And to be clear, these ran an AI developer workflow, not an orchestrator developer workflow. Okay, the orchestrator just fired this off and walked away. Okay, and why is that? It's because this is very powerful, but here we're relying on non-deterministic systems for these large, massive chains, these huge jobs, right? The last piece to our class 3, grade 3 system is this. It is maybe what you would expect. It's the highest leverage point of agentic coding once again. Okay, AI developer workflow plan build. The big difference between our orchestrator developer workflows is that this can use raw code. Okay, you know that I am ultra agent forward, but none of it matters if we can't track it, observe it, control it, and make sure that it's all running properly. By giving our orchestrator the ability to run AI developer workflows, we now reach the final stage and we reach something like this. Some user interface like this, some process like this, some code base like this. This code base will be available to you. This is my final gift to you here in Agentic Horizon, so you can understand how you can build out something like this. This is just a vision, it's an example, right? We now have both the log stream view and we have the ADW's view, so you can see these full end-to-end pipelines where we move closer and closer towards zero-touch engineering and the code base singularity. Okay, this is the final level. This is class 3, grade 3. We have now given our orchestrator agent everything it needs to run our code base, right? And the big piece where we can have high trust in this system is through our AI developer workflow, right? So just imagine you have tons of these that do entire workflows, right? You've built out, different triggers. You've improved your modules, right? We have tons of prompts now. And this is, of course, is just an example code base, right? This is where you really can scale your compute to scale your impact super hard because you have so many tools at your disposal, all controlled and guided by an orchestrator agent, a custom agent that you've taught how to run your code base. The big final missing piece of a class 3, grade 3 agentic layer. There's a lot here, lot to digest. We've worked through multiple grades, multiple systems. The goal here is not to try to climb to the highest class. Of course, this will give you the highest impact. The goal here is to recognize where you are. What pieces do you have? What pieces are you missing? You may have skipped some things. You might have some out-loop agentic coding system that you're working in, right? You have taken tax, so that would make sense. But maybe you're missing agentic workflows, right? Maybe you're missing prompt chains. Maybe you're missing agent experts. A lot of engineers are probably missing agent experts. The goal here is to identify the missing pieces you have and then make a plan for building them into your code base test it, see how it feels, see how it progresses you, see what you can do with it, right? Every one of these classes is going to give you a new capability, right? From class 1 to class 2, we get out of the loop and we start relying more on our agents. This is a hard transition to make. Class 1 to class 2 to class 3, it's a different type of agentic coding. We're doing out loop agentic coding here. And we move to class 3, we're doing orchestrated agentic coding, all right, where we have an orchestrator agent commanding our teams. It can be involved in the prompt. It can run its own AI developer workflows, but it all leads to the same place. Zero touch engineering, where we knock on the doorstep of the code base singularity. This is the North Star of TAC. This is the North Star of Agentic Horizon. You want to push your agents to engineer like you can and better than you can, all right? So let's boil this all back down. What has happened? What have we learned in tactical agentic coding and Agentic Horizon? First, we stop coding. Use the best tool for the job, agents. If you're still writing code by hand, you will not get to any sufficiently complex level of your agentic layer. You must adopt your agent's perspective. Think as your agents would and give them the leverage points it needs to ship. Imagine you are your agent. Right before you hit enter, right before you pass in that context, with this information, could you solve the problem you're going to ask your agent to solve? This is critical for knowing how to build out teams of agents, all right? Template your engineering. If you cannot encode what you would do into your prompts, into your plans to create these templates, you will not get repeated agentic success, because your agents will jump off ship. It'll do random things. These are non-deterministic. No matter how good they get, these models will change in nature. When you template your engineering, you're giving your roadmap to success. You're giving your engineering best practices, right? You're saying, this is how we solve bugs. This is how we build out API endpoints. This is how we integrate with this service. This is how we do X, Y, Z. And you teach your agents to do that. You must template your engineering into your agentics. Next, we stay out the loop. Once you start scaling up these agentic workflows, also known as prompt chains, and you start building out these great skills and great subagents, it's time to get out the loop. This forces you to build the system that builds the system. You want agents that can run while you're not there. You will not scale your agentic layer if you are stuck in the terminal prompting back and forth and back and forth. You must stay out the loop. Tactic 5. Always add feedback loops. If your agents are causing bugs, they're not working properly in your system, you probably just haven't given them the right tools to reflect on their work and make correction. Use closed loop prompts to have your agents validate their own work. More compute should equal more trust, not less. If it's less, you're doing something wrong. Request, validate, resolve. Now, one of the most important tactics of all, you want to be building one agent with one prompt with one purpose. Why? Because a focused agent is a performant agent. It's the exact same thing for you and I. If you have multiple tasks, if you're feeling scattered, if you keep context switching, you will make mistakes. This effect is exaggerated in our agents because they have limited context windows. Throw 2 problems in there and the chance they accomplish both go down. Throw just one, make it super clear, and be precise with your details, and it will very, very likely, in fact, it will have the highest chance of accomplishing that one task, okay? With the orchestrator agent, we can do this better than ever because you just spin up agents when you need them, and then when you're done, you delete them. One agent, one prompt, one purpose. Don't fight the context. Use it to your advantage. Let your agents focus. And once you really hone in context engineering, prompt engineering, you can start targeting zero-touch engineering. This is not a dream anymore. It's not a meme or a distant thing in the future. This is what some engineers are doing right now, okay? And like I mentioned, there is a configuration of your agentic layer that can be built right now inside of your code base that is so powerful, your code base runs itself. But you have to have this as the target. This is the North Star of TAC and Agentic Horizon. Target zero-touch engineering, because when you do this, you move closer toward that code base singularity, the moment when your agents can ship better than you and your team. This is not something to fear, it's something to run toward. This is in the future. So the question is, how far are you from this? Are you pushing toward this or not? And finally, all of this can be boiled down into one meta tactic, right? Prioritize agentics. Build the system that builds the system. Prioritize your agentic layer, okay? And that's been the focus of this final lesson. It's all about the agentic layer. You're building the machine that builds your product now. You're building the system that builds the system. This is the highest leverage activity for any engineer now. We then pushed into agentic prompt engineering, where we talked about powerful prompt engineering. This was the first lesson of Agentic Horizon. We moved into elite context engineering. All these tactics, all these ideas, they don't matter if you can't prompt and manage your context window of your agents, right? And again, this is where one agent, one prompt, one purpose comes into play. Manage that context window with the R&D framework. If you want to build programmatic agents, you must learn how to build custom agents. In this lesson, we looked at 8 different custom agents deployed into applications. This is how you build the orchestrator. If you don't know how to build custom agents, you're at a massive disadvantage for not just code-based specialized agents like the orchestrator, but for all types of product-focused agents, all right? Then we looked at multi-agent orchestration, the next paradigm of agentic coding. First, you're in the terminal, then you get out the terminal, you're running your agents and your teams of agents from an external service, and then you build a manager of your agents that then you run against, all right? Multi-agent is the future of agents. There's no way to accomplish the amount of work we need to accomplish without multiple agents. So why not teach a specialized agent how to run your systems? And then finally, we looked at agent experts. This is the most slept on, highest return on investment opportunity for engineers. You can build experts into custom agents. You can build them programmatically. You can customize the system prompt, all the tools, your user prompts to build a specialized agent that solves one problem extraordinarily well. This is the future of product and code bases with agents. They are experts. They do one thing very well. Okay, all 13 lessons are now available to you. You have access to these. Please rewatch these. These are not one-shot videos. I built these to stand the test of time. These are the tactics and the skills that you'll need to win in the age of agents. Everything comes down to this. In the beginning, we set out to become an irreplaceable engineer in phase 2. The phase of agents is the phase of agentic coding. It's the phase of agentic engineering. We are now commanders of compute. We're using teams of agents to accomplish work on our behalf. We teach our agents how to build like we can, and then we scale it. We go from base to better to more to custom to an orchestrator that runs it all for us. We've painted a complete vision of what this looks like. We've shared code, we've shared ideas. It's been incredible building this for you over the past couple years. Thank you so much for trusting me. It takes so much effort to build out these ideas, right? To synthesize it and to really make it something that I can share it's extremely challenging. And then to trust someone to deliver on these ideas is a risk that you took. So I want to really thank you and appreciate you here. I want you to take these ideas and win. I am always trying to boil down the most powerful ideas for engineers into their atoms and just hand them to you and say, solve your problems, build your company, deliver value to your users, because that's what it's all about. This is engineering. Tools will change, models will improve. We know this. There will be constant, endless change. But what you have now, what you're equipped with are concrete tactics of agentic engineering and raw skills that allow you to control the most important tool of engineering, agents. The agents are on the horizon. This has been Agentic Horizon in an endless sea of slop, noise, and fake hype and misdirect. Everything comes down to raw experience from day one. I couldn't have built any of these courses, any of these lessons without putting my boots on the ground every single day, just like you, and building with this powerful technology. I sit down every single day and I ask myself the same questions I've asked you. How can I scale my compute further? What are the best agents? What are the best models? How can I build the best tools? What does the greatest agentic workflow look like? How can I increase my observability? I'm obsessed with these big ideas, and when I can, I'll be sharing them with you on the channel. So you'll be able to find me there. If this is the last course we're in together, I just want to say once again, thank you for trusting me. There is one idea I want to leave you here with. It is the big idea we ended tactical agentic coding with. I want you to imagine yourself in the future, looking back at this moment, thinking, this: when the agents arrived, something changed. We weren't just AI coding anymore. We started orchestrating intelligence. Since you made it to the end of Agentic Horizon, I want to paint a picture of what my next plans are for pushing agents, for pushing generative AI, and ultimately for becoming a highly proficient agentic engineer. Over the next year, I'm going to try to accomplish something no engineer has before. I'm going to build a product using all the tactics of agentic coding and all the skills and key ideas from Agentic Horizon, and I'm going to record the entire process end to end. The process of building a valuable 4 to 5 figure per month business that runs on agents. This is going to push me to my very limits. I don't know if I'll succeed. I might hire a small team to help me accomplish this, but ultimately I want to take on this challenge to prove to myself and to prove to you, the engineer, what you can really do with this technology. I want to showcase that if you invest in the right places, in the right people, and the right ideas, that you can truly increase your engineering ability by orders of magnitude. So if I'm successful here, you and other Agentic Horizon members will be the first to know. And this is something that I might potentially roll into the next course. If I fail, I am not going to be building another course. I am not going to be putting out another product on my own, probably for some time. The stakes are here, the pressure's on, and I can't wait to create the future where I can share the next generation ideas of agentic engineering with you, where what a single engineer can do is no longer limited. If I'm successful, you'll be the first to know. Once again, at the end of the road here, I want to thank you for trusting me. I'll see you on the channel. We'll continue to push what we can do, and maybe there you'll see glimpses of what's coming next. I want to make this super clear. If you take the ideas from TAC and AH and apply them, really put them to work. If you trust me one more time, if you do this right, it will change everything.